Hello my dear students, we can move to the next lesson, that is machines. We use different types of machines in our daily life, both simple machines and complex machines such as screwdriver, scissors, washing machine, etc. All these machines are used to make our work easier and faster to do. As we all know, no machines work by itself. We have to give some force to work the machine, and the force that we have applied on the machines to work it is called effort, or effort is the force which we applied on the machine. Now, if I want to lift this duster, I have to give a force equal to the weight of the duster, and it should be in opposite direction of the weight. So I have to overcome the resistive force offered by the weight of the duster. Am I right? So in this case, the weight is the resistive force. A machine also has to overcome some resistive force, and the resistive force which a machine has to overcome is called load. So load and effort are two main forces related to machine. So I will explain the definition of load and effort once again. Load is the resistive force that a machine has to overcome, and effort is the force applied on the machine to overcome the load. Now, let's look the functions of a machine. All machines are useful for us in any one of the following four ways. I will explain you it with some examples. First of all, in the case of a screw jack. A screw jack is used to lift a car. As we all know, our force is not enough to lift a car. Hence, we use a screw jack. So, screw jack make it possible to lift the car with our effort. How is it possible? Suppose I can be able to apply a maximum force of 100 Newton, and car needs 1000 Newton force to lift. So, to lift a car, it needs 1000 Newton force. So, here the load is 1000 Newton, and the effort, the maximum effort I can be able to apply is only 100 Newton. So, when I use a screw jack, the screw jack multiply this force to 1000 Newton, so that I can be able to lift the car with my force. Here, the screw jack multiplies the force. So, the screw jack serves as a force multiplier. This is the first function of a machine. A machine serves as a force multiplier. Here, my effort is multiplied by 10 times. Is it? So, what is the advantage here? My effort is multiplied by 10 times. And this advantage is called mechanical advantage in physics, and the symbol of mechanical advantage is MA. So, mechanical advantage is MA. Okay, so we can define mechanical advantage as the ratio of load by effort. Look, load is 1000 Newton and effort is 100 Newton. So, 1000 by 100 will give us 10. So, the ratio of load by effort is called mechanical advantage. Now, this ratio 10 is greater than 1, is it? So this 10 is greater than 1, and so mechanical advantage can be greater than 1 here. So in all the force multipliers, the mechanical advantage will be greater than 1. In all the case of force multiplier, the mechanical advantage will be greater than 1. Think yourself. In all force multiplier, effort will be less and load will be more. And load comes in the numerator and effort comes in the denominator. So on cancelling, we will get a value which is greater than 1. So mechanical advantage will be greater than 1 in the case of force multipliers. Let's look the next example. It's a grass cutting machine. Cutting of grass is easy since it does not offer a large resistive force. But we use a grass cutting machine to complete our work with less time. In such cases, machine help us to complete the work in a faster way. So here, it is used as a speed multiplier. Now, here in this case, we should give much more effort than the load. That is, effort will be greater than load. And here, what will be the mechanical advantage in this case? See, mechanical advantage is load by effort, is it? In effort is in the denominator and effort is the larger value. So larger value comes in denominator and hence mechanical advantage will be less than 1 in this case. So in the case of speed multiplier, the mechanical advantage will be less than 1. What is the advantage here? Here, the machine increases the speed of our work, or machine is used as a speed gainer. In such case, the speed of the load is much more greater than the speed of the effort. The effort has less speed and the load has more speed. Since output is on the load, the speed of the load increases. That means the speed of the output is more than the speed of the input. And here, if you take the ratio of speed of effort by speed of load, or velocity of effort by velocity of load, it is called velocity ratio, and the symbol of velocity ratio is VR. So, velocity ratio is VR and it is the ratio of velocity of effort by velocity of load. Since load has greater speed, in this case, velocity ratio is less than 1. In which case, in the case of a speed gainer, velocity ratio is less than 1 since velocity of load is greater. So, velocity ratio is less than 1 here. So, what will be the other case? That means on the force multiplier. In the case of a force multiplier, the load is more than that of effort. Hence, mechanical advantage is greater than 1. But the movement or the speed of the load is less than that of the speed of effort. So, load is more but speed of the load is less. Hence, velocity ratio will be greater than 1. Don't be confused. Velocity ratio is velocity of effort by velocity of load. So, load is coming in the denominator, and in the case of force multiplier, velocity of load is less, so velocity ratio will be greater than 1. So, mechanical advantage and velocity ratio is very important, and also velocity ratio is velocity of effort by velocity of load, is it? So here, what is velocity? Velocity is displacement by time. So we can write velocity of effort as displacement of effort divided by time interval, and velocity of load as displacement of load by time interval. See, velocity ratio is velocity of effort by velocity of load, or it is displacement of effort by time divided by displacement of load by time. We all know load and effort moved for a same interval of time. So we can cancel this time so that we can write displacement of effort by displacement of load. So velocity ratio can be defined as displacement of effort by displacement of load in the same interval of time, since we are moving load and effort in the same interval of time. So this is about velocity ratio. Now let's look the third example of machine. Here a pulley is used to lift water from the well, and here the use of pulley is just to change the direction of effort, and we all know that we are convenient to give a force in downward direction, but to lift water from the well, we have to apply a force in upward direction. It is difficult for us, is it? So here pulley is used to change the direction of our effort. So using a pulley, we can apply the force in downward direction and the water will come in upward direction. Here pulley is used to change the direction of effort. The resistive force offered by the load and the effort we are applied on the string will be equal, and hence mechanical advantage is equal to 1, and also the distance travelled by the load and the distance travelled by the effort will be same, and hence the velocity ratio also will be equal to 1. And let's move to the fourth function of a machine. Here a bicycle is moving, and this movement of the bicycle is possible by the rotatory motion of the rear wheel. But the pedal of the bicycle is not in the rear wheel, and we are applying the force on the pedal. The long chain changes the point of application of force from the pedal to the rear wheel. Thus, the point of application of effort is changed from pedal to the rear wheel. Here, machine help us to change the point of application of effort to the convenient point. Here also, load and effort will be same. Hence, here also mechanical advantage and velocity ratio will be equal to 1. My dear children, please look at the table. It explains all the 4 functions, mechanical advantage and velocity ratio in detail. First of all, when a machine works as a force multiplier, mechanical advantage, that is load by effort, in such case load will be greater than effort, so mechanical advantage will be greater than 1. But displacement of effort will be less than that of displacement of load. Hence, velocity ratio, that is displacement of effort by displacement of load, will be greater than 1. So, in the case of force multiplier, mechanical advantage will be greater than 1 and velocity ratio also will be greater than 1. Now, when a machine functioned as a speed gainer, mechanical advantage, that is load by effort, since effort is greater than load, mechanical advantage will be less than 1. Also, velocity ratio, that is displacement of effort by displacement of load, will be less than 1. Hence, mechanical advantage and velocity ratio is less than 1. Now, when a machine is used to change the direction of application or point of application of force, load is equal to effort, hence load by effort. When it cancels, we will get 1. So mechanical advantage is equal to 1 and displacement of effort is equal to displacement of load. Since both travels at same distance in same interval of time, velocity ratio also equal to 1. So here mechanical advantage is equal to 1 and velocity ratio also equal to 1. Mechanical advantage and velocity ratio are two quantities with no unit since they are ratio of two similar quantities. Now, as I explained to you in the beginning, a machine is a device which makes our work easier to do. So, machine is related to work. Now, to work a machine, we have to apply a force and we have to move the handle of the machine through some distance. So we have to work on it, is it? And work done by us on the machine is called work input. The force applied by us on the machine is called effort. So we can say work done by the effort on the machine is called work input. So what is work input? Work input is the work done by the effort on the machine. So work means force into displacement. Here force is called effort. So work done by the effort. So effort into the displacement traveled by the effort is called displacement of effort. So here work input is equal to effort into displacement of effort. So work input is the work done by the effort on the machine and it is equal to effort into displacement traveled by the effort. Now the machine works on the load or machine works to overcome the resistive force offered by the load. So we will get the output work on the load. Hence work output is equal to work done by the machine. There the machine is doing the work and hence it is work done by the machine. Where is it doing the work? It is doing its work on the load. So work done by the machine on the load is called work output. So here the force is used to overcome the resistive force offered by the load. Hence here the force is load and when it does the work it moves the load. So here work output is equal to load into displacement traveled by the load. Hence work output is equal to load into displacement traveled by the load. These are the two works which is related to machine. Work input, that is work done by the effort on the machine, and work output is the work done by the machine on the load. Okay. Now the ratio of work output by work input is called efficiency. So efficiency is the work output by work input, or the ratio of work output by work input is called efficiency, and the symbol of efficiency is this. This is called eta. Symbol of efficiency is eta, and the efficiency is work output by work input. Today we have learned the 4 functions of machine and the terms related to machines. So machine is a device which is used as a force multiplier or a speed gainer, or to change the point of application of force to a convenient point, or the direction of application of force to a convenient direction. The main terms related to machine are load, effort, mechanical advantage, velocity ratio, work input, work output, and efficiency. Load is the resistive force that a machine has to overcome. Effort is the force applied on the machine to overcome the load. Mechanical advantage is the ratio of load by effort, and it has no unit. Velocity ratio is the ratio of velocity of effort by velocity of load, or it is the displacement of effort to the displacement of load at the same interval of time. Velocity ratio also has no unit. Work input is the work done by the effort on the machine, which is equal to effort into displacement traveled by the effort. Now, work output is the work done by the machine on the load. It is equal to load into displacement traveled by the load. Now, efficiency is the ratio of work output by work input. Since it is the ratio of two similar quantities, efficiency also has no unit. Hope you all understood all the terms related to machine. Thank you and have a nice day.